So now that you know a little bit about the line of best fit, we're going to actually talk about how to find it if we're given a table of values, okay? So in these directions, it says find the least squares regression line. In other words, the line of best fit that fits this data, okay? So for the first one, you're given a set of years that I guess that they've made observations about, and then money. And so now we're not given much more information than that. So it might be like how much money they had in each year. We're not really sure, okay? And so I'm going to tell you and talk to you about how to use Desmos to give you the line of best fit, okay? So what you'll do is you'll go to Desmos. You're going to, and so here's the steps, so you can write that down and kind of follow along with me. But you're going to hit the little plus button on the side here, and you're going to click table. And then you'll notice that a table pops up. Then you're going to type in your values, okay? Now, as to what you type in, if they tell you a certain set of directions, you're going to do one thing. If they don't tell you, you can type the data in as it is, okay? And so what I mean by if they tell you or give you some directions is when they give you years, every now and then they might tell you to, for instance, they might say label the X values as years since a certain date. So if they do that, so it would be years since, and they might, like for this problem, say label it as years since 1993. And if they do that, then you have to actually relabel the X values, which is years in this problem, with different numbers. So like if they said that the X values were supposed to be the number of years since 1993, well, what you have to do or go and do is figure out how far each of these years are from 1993. So like 1993 is 0 years from that year. 1994 is 1 year from 1993. 1995 is 2 years. 1996 is 3. So on and so forth. This is 4 years, that's 5, that's 6, and that's 7 years since 1993, okay? And so when you type in your table, you would be typing in these numbers instead of the actual year, okay? Now, if they don't tell you to do this, then you could do it either way. You could go back and rewrite them as the numbers I wrote down, or you could write them as the years. And so since they didn't really tell us to do that in this problem, I'm actually just going to enter the data in as the years as they are, okay? And so you just go through, type in your X values, so 1993, 1994, so on and so forth. Make sure you don't mistype stuff, because I know sometimes, including myself, that we get kind of quick with typing things and then we just accidentally mistype and then it messes up our whole problem, okay? So there's my years, and so from there I'm going to type in the Y values that go with them. Oh, didn't mean to type in an extra there. So then that's 369. Okay, and so let's double check. Okay, and so once you get your data entered, you're going to have to go back up here and you're going to enter an expression now. So you hit expression and notice another one will pop up down here. And then you're going to actually type in the equation, the type of equation you're looking for. And so we're writing the line that best fits the data. So like if we were to graph that scatter plot, which notice that this is actually graphed for us, we just can't see it because it's got big numbers. So if like I zoom out quite a bit, I'm going to have to zoom out a lot, you'll start seeing your dots. So there's your dots. And so if you wanted to zoom in on those, you can zoom in. You just have to kind of adjust and drag your table where you need it. Okay, so there's my scatter plot of my points. And so once you have your scatter plot, then you are going to type in your equation. So now the equation is going to look a little bit different, okay? So usually for a line, it's going to be y equals mx plus b. Notice it is similar, but because they are going to be approximating the line that goes through those points, we're going to have to change things a little bit, all right? So when you type this in, you're going to have a little squiggly, or what's called a tilde, instead of an equals, because this is going to approximate a line that best fits those points in the scatter plot. And it's going to be based on my table. So that's why you see like a Y1 and an X1 here, because you are going off of the table. Okay, so you're going to start typing. It's going to be Y. And then if you type the 1, you'll notice it automatically goes as the little subscript. Then you'll type the little squiggly, which if you're on a normal keyboard, it's going to be right beside the number 1 button. And then you type in an M, and then one is whatever's right here has to match what you type in the equation, okay? And then it's y equals mx plus b, so you have to type in a b. And so notice there's been a lot of stuff that's kind of been popping up off and on as we do this. That is information about this line. And also notice it's been graphing that line as we've typed it in, okay? So this would actually be the line that best fits that data. And notice it does go through my points, okay? So where do you get the actual equation from? Notice down here you've got an M and you've got a B. That is your M and your B, your slope and your y-intercept in your equation. So all you have to do is write that down and plug it in. So the equation of a line is y equals mx plus b. So now all you have to do is plug in your M and your B. So it would be y equals my M, if you look right here, my M is 32.33, so it's going to be 32, and I'll just put a couple 3's, and then it's X, and then my B is the negative 64,104, so minus 64,100, and actually it's not a 4, it's a 5, okay? That would be the equation of the line that best fits that data, and you can see it definitely goes through the middle of those points, okay? So let's do one more where you just write the equation of the line, and then we'll do a different type of example. And now I do want to point out before we move on, if you typed in these as your years, your equation will look different because you would have different X values, okay? And if you were using this to make predictions, you would have to calculate, like if they might ask you, how much money would they make in the year 2008? Well, if you were doing it this way with these numbers, you'd have to figure out how far 2008 was from 1993. Whereas with the way that we did it, all I'd have to do is just plug in a 2008 right there, and it would give me my answer. Okay, so there's an advantage to being able to type the years in as they are. All right, so the next problem, you'll notice we're comparing, and we've collected data comparing fat and calories. So maybe I was looking at different foods, and I was writing down how much fat they had compared to how many calories they had, okay? And so, like a food that had 6 grams of fat had 276 calories to it, so on and so forth, all right? So if we had to write the line that best fits that data, I would do the same thing. I would go to my Desmos, and let's say that I wanted to leave this table for some reason. Maybe I needed to use it for something else. So then you would just add another one. And now notice when I add the next table is going to put an X2 and a Y2 so that it's different than this table up here, okay? So then you would type in your data. So I'm just going to go through and type in my data. So I've got my X values. So then I've got 19 and 20, 27, and then 36. And then I'm going to type in my Y values. So my Y values, this one had 276 calories to it, that one 260, 220, 430, 550, and then 633, okay? And so once you get your data entered in the table, once again, you hit the plus expression, and now you're going to have it give you the equation. So you'll type in Y, and this time, notice I said it's got to match your table. So now I have to type in a Y2. And again, you just type the 2, and again, you have to match that X with the ones from your table, and then plus B, okay? And now, I automatically have the equation. So my equation, and then you write it like normal now. Okay, so it would be y equals my m. If you look right here, my m is, and if you're, sorry, side note, if you're using this equation to make predictions, which we will in the next video, I would recommend actually writing out at least 4 numbers past the decimal in these equations so that your predictions will be as close to accurate as you can be, okay? And so my slope, notice I wrote out, and then that's the number in front of x. And then my y-intercept, if I look right here, is a positive 150.869. So we put plus 150.869. So that's the equation of the line that best fits that data, okay? So just kind of looking at our data here, remember the slope is how fast or the rate that something's changing. And since it's a positive slope, that means that there is a positive relationship between these two. So something that I could notice is as the fat and grams increased, then the calories also increased, okay? Something else is the y-intercept here. So the y-intercept in this problem I probably wouldn't look at as much, but this would be my y-intercept if it had to do with kind of the data I was looking at, all right? So notice for this one, if I go and find that in my scatter plot, it's around the 6 to 36. So I'm going to zoom back out a little bit because my other one is graphed. Oh. Let me exit out of this. And that way it'll graph that one. So let's see. There we go. So if I look at that scatter plot, notice it's got my points plotted, and that line kind of goes through the middle of them. So this one wasn't quite as spot on as the other one was, just because the other one looked like it goes straight through, it went straight through the points. But this one, the closer we get, you'll notice that the line actually goes through the middle of your points, but the points don't perfectly form a line, okay? So there's not a perfect linear relationship between fat and calories, okay? So the last problem that we're going to talk about is what happens when they give you a graph and you have to write the line that best fits that data. So if you kind of drew the line, it would kind of go through them kind of like that, but you have to actually find the equation. So you could take your points straight from the graph and put them in the table on Desmos, or for myself, I always like to draw my table and then put it in Desmos, all right? So we're comparing days with money. Okay, and I'm just going to take each point and write it down, and I usually go from left to right. So 2 is with 10, so on day 2, I guess I made $10. On day 3, I made $20. On day 4, 10. And then day 5, $25. And then day 7, I made 25. Okay, so now I just take that. So notice I took it from the graph and put it in a table. Now I'm going to take this and put it in a table on Desmos. So, see if it'll let me do this. Oh. There we go. All right, and then I add another table, and so I'm just going to type in my data. So we got 2, 3, 4, 5, and 7. And then for the money, we've got 10, 20, 10, 25, 25, and 25. All right. Then you go down here, you type in your expression. So notice I'm going to be typing a Y1 because the table has a Y1 and an X1 in it. And then it's M times X1 plus B. And then there's my equation. So I just write down my equation. So it'd be Y equals 2.8378X plus 6.081. So that is the equation that best fits that data. All right. So if I looked at my scatter plot, let me zoom out. There we go. There it is. And then I'm going to zoom back in to look at it. that is the line that best fits that data. So there you go.